Hi, welcome to today's APO Productivity Talk. My name is Rie Minamoto, and I am a Program Officer for the APO Secretariat. Today, we have a very interesting topic, from lean to smart manufacturing. Our main question is, how lean production and Industry 4.0 can mutually enable an integrated approach to productivity improvement in the manufacturing sector. For the presentation and discussion on this topic, we will have Dr. James Chen, Professor of National Tsing Hua University in the Republic of China. Good afternoon, James. It's great to see you.
Hi, good afternoon, Lee. Nice to see you again. Good
Yes.
afternoon, all the participants.
Thank you very much for joining us today. At first, I will introduce you a little to viewers. Dr. James Chen is a professor in the Department of Industrial Engineering and Engineering Management at National Tsing Hua University in the Republic of China. He is also adjunct professor at the Institute of Industrial Engineering at the National Taiwan University. He has published more than 100 international journal papers and has been working closely with the industries in lean production and smart manufacturing for more than 30 years. Prior to his current position, he was a chair professor in the Department of Industrial Management at the National Taiwan University of Science and Technology, a professor in the Department of Industrial and Systems Engineering at Tsing Hua Christian University, and a researcher at the Industrial Technology Research Institute. He received a bachelor's degree in industrial engineering from National Tsing Hua University, a master's degree in manufacturing systems engineering, and a PhD in industrial engineering, both from the University of Wisconsin-Madison in the United States. Today, Dr. James Chen will discuss the opportunities arising from smart manufacturing and the challenges that companies may face in adopting it. He will also share lessons learned from cooperation with industries in their lean production and smart manufacturing journeys. After his presentation, we will have an interactive Q&A session. So if you have any questions for Dr. James, please post them in the YouTube chat box. Please leave your name and country too. We'll answer as many questions as time allows. Without further ado, we would like to proceed to the presentation. So James, the floor is yours.
Okay, many thanks, Lee, for the introduction. So today, I'm very happy to be here to give the presentation of the topic from lean to smart manufacturing. I will follow the outlines as following. First, give some discussion about the challenges and the opportunities we are facing, and then talk about why we need to go for lean and the smart manufacturing. Then give some brief introduction of the lean production and the smart manufacturing. After that, we will take a look at the lighthouses for the benchmark and see their digital journey and the lesson learned. Finally, I will give some remark from lean to smart manufacturing. Most of us experienced the evolution of the industrial production. And now we are facing the challenges in the era of the Industry 4.0, including the cyber physical system, IoT, and the others. If we review the trend of production volume versus the product variety, we could see the very interesting curve like this one. Okay, so this is the special curve that we normally do not see in the analysis of some figures. So the vertical line and the horizontal line shows the variety and the volume. Okay, so in the period of the 1850 to 1913 is the craftsman production. The volume is very low, right? The variety is high. Different customers ask for their favorite. And in the period of the 1913 to 1955, this is for the mass production, especially by American company Ford. Okay, so the production volume jump up, but the manufacturing cost dropped. So the customer enjoy the low price automobile. So since the year 1955 to 1980, this is the period for the lean production. And the Toyota is very famous in this area because Toyota really reduced the cost and also maintain the high variety for the product for the customers. So after the year 1980, lean production and the Toyota's production system retains, but the customer asks for more customization. So if we review the statistics in the year 1979, comparing the performance by Ford and the Toyota, we could see in the labor cost per vehicle, capital per vehicle, and the work in process value per vehicle, Toyota outperformed Ford significantly, right? The difference is not, for example, 50%. It's several times. Okay, so that's the reason many industries try to learn from Toyota. So if we review the cost, time, and the variety in the mass customization compared to the mass production period, when we are doing the mass production, variety is low, cost is low, time is short. Okay, this is easier to manage. But now if the customer is not satisfied with the single product, they want the variety, they want the customization, then high variety, high cost, and a long time, these are the challenges any factories need to manage. Okay, so let's review the evolution of the KPI or some highlights for the industry. Back to the 100 years ago, scale is important because people are moving from the handicraft era to the mass production target. Okay, so if we could do the mass production, we reduce the cost, and then we need to maintain the quality. So more highlights are maintained by the manufacturing factories, like the lean production, flexibility, delivery, automation, e-business, speed, service, knowledge management. Okay, so these are the hard terms in the decades in this period. But nowadays, more interesting terms become more and more popular, including the innovation, cloud computing, big data analytics, IoT, smart manufacturing, Industry 4.0, and now AI are the hottest topic surrounding us. Okay, so AI is hot, but how about Lean and the Toyota? All right, so we like to see the popularity or readers' interest for these terms, the keywords. So let's go to the Google trend. All right, so if we see the big data IoT compared to Lean, Toyota, and the AI, these hot terms are not so hot. Okay, Lean and Toyota has been very hot over the period from the year 2004 even to now. But AI is hotter, maybe last year to this year, right? But if we consider average, Lean Toyota has the higher average of the voice in the internet than AI. But we expect AI will be getting the even more attention from the people worldwide. All right, so let's review the reason why the factories need to go for Lean and the smart manufacturing. That's because the change in the profit model due to the globalization. In the past days, the globalization was not popular. So the factories could determine their cost plus the profit to set the price. So if the customer cannot find too many choices to buy the products, okay, they may negotiate the price with the vendor, and eventually the vendor, the factory, could keep some profit. So the profit model will be like this one: the cost at the profit to determine the price. But now, due to the globalization, the market determines the price, right? Generally, no single company could determine the price by themselves. Okay, so the model becomes the price minus cost to be the profit. So if any company could reduce the cost, they could gain the profit. But if any other companies who cannot control the cost well, they cannot make the profit. So for the company losing the money for years, they cannot survive in the market. Okay, but people may say, all right, due to the trade war between America and China, the globalization is broken in some sector. But still, the new model retains because right now, generally, customers have many choices to buy the product from different vendors. All right, so we are here. We need to try our best to reduce the cost. Okay, so let's review the customer's want and need, including many items: the cost, quality, on-time delivery, service, supply chain, resonance, and the ESG. All right, so these are all important. But if we discuss with the procurement department of the company, generally they will say the cost is the most important. All right, even though they ask for the quality and the on-time delivery, but they care about the cost the most. All right, so we know the cost is important from the perspective of the customer. So what should a factory do to improve? Let's try the two cases from my experience in the cooperation with the industries. So one company, they installed one auto screw driving machine at the assembly line. All right. So this is a typical automation device for the assembly of the electronics devices. Okay, so after this automation, they replaced two assembly operators. The ROI is about 1 year. Is this good? Yeah, the pretty good. The management of the factory is happy to see the result. But can we make it better? The answer should be yes. All right. So think about before we do the automation. Did we try to use some improvement Kaizen tools like the ECRS, eliminate, combine, rearrange, and simplify to do the improvements? ECRs may not invest too much, but we may save, for example, half operator or even one operator. How about we do the line balancing, consider the ergonomics, human factor, or improve the jig fixture tool for the Kaizen? All right. So I think if we do the red part first, we may, install some automation equipment to save more operators to get a better effect. Another example, one company installed one autonomous mobile robots or some AGV system, right? The automatic material handling. Okay, the influence impact is high. They replace 6 material handling operators with the system. May include, 3 AGVs. ROI is about 1.5 years. Again, this is good, right? Yeah, I think this should be a good investment because after 1.5 years, they, could gain the benefit every year after this period. But again, we should be able to make it better, right? By the same ECRS. For example, do we consider the relayout? If the frequency of the movement between two stations, why don't we move the stations closer to each other, right? Save the travel distance. How about the conduction of the flow analysis and improvements? Yes, if we could do this red part Kaizen, I think the impact could be even more. All right, So based on the previous example, I think when any company is caring about the 4 blocks with the Lean Toyota Production System, EB, digitalization and the digitalization, automation, and the smart manufacturing, there should be a sequence to execute the projects in these 4 blocks. That is, we go for Lean TPS first, and then go for digital and the automation later. Eventually, if we have the data in the data warehouse, it's possible for us to go for the smart manufacturing. All right. So please follow the sequence. Otherwise, we may not get the benefit from the investments. Okay. So since we feel Toyota production system, Lean production system is important. So what are the elements of this philosophy? Okay, the Toyota way. So this is the house of Lean or house of the Toyota production system. The roof is the target. The best quality, lowest cost, shortest lead time, best safety, and the high morale. All right, we like to have this as our target objectives. There are 2 pillars, the JIT, the right part, right amount, right time. We talk about the take time, right? Continuous flow, persistent, quick changeover to save the changeover time. So we could have the small batch production. Jidoka, okay, automatic stop when there is a problem. And DON system, we separate the person and the machine. All right, we like to have the Kaizen, continuous improvements, people, teamwork, and we identify the waste. Right, we want to have the SOP to show the standardized process, visual management to see the problem. Okay, so why people go to learn from Toyota? If we review the 15 years for the period from the 2004 to 2018, for the key players in the automobile market, Toyota, Ford, Volkswagen, and GM. Yeah, these are the top 4. Toyota's curve is this one. Okay, so Toyota in general is the best, even though not the best for every single year, right? For this one, the year 2011, after the economic recession, Ford was the best for this single year. But in general, Toyota was the best for most of the years. All right, GM was losing money in this year, 2007. Okay, so how about the summation of all these 15 years? The vertical line shows the billion of US dollars. Okay, so we could see Toyota was really good. One single company gained 180 billion US dollars over the 15 years. This number is more than the summation of the 4 other competitors. Okay, but if we say, okay, GM lost the money, so we don't consider GM. How about the summation of Ford, Volkswagen, and Honda? Yes, Toyota's single company's profit is more than the summation of these 3 positive profit earning companies. Okay, so this may explain why people are learning from Toyota for their production system and management philosophy. So when we want to benchmark Toyota, we must know father of TPS, Sir Taiichi Ohno. So 10 precepts are some of the wisdom we learn from him. First, you are a cost. First, reduce the waste. All right. So this is very good point because every management, every employee get the salary from the company. So the contribution of the individual should be more than the salary. So the company could make the profit, right? So anyone should say, I could do it, then try before everything. The workplace is a teacher. You could find the answers only in the workplace. So we do the Gemba on the shop floor to see the problem, to improve because of the problem is the opportunity, right? So waste is hidden, do not hide it. make the problem visible. Okay, so this is the visual management. Okay, re-improve what was improved for further improvements. Okay, this is the word I normally remind the factory management. Don't say we did this before, right? Still problem is there. We could make it better. All right. So the identification and the elimination of the waste. People say the 7 waste or 8 waste. If we add one more, not engaging all, we like to use the creativity of the employees, right? So if we use the teamwork or downtime for people to remember this waste easy. So the topic for the Lean Kaizen project, I help the company to go for the Lean and the smart manufacturing, may include these typical topics. Cost down. Okay, if we reduce the cost, of course, we could make more profit. How about the headcount reduction? Right now, factory has the difficulty to find good employees. So how about use the automation to replace some employees that do not add significant value to the product, to the customer? And how about the efficiency improvements, line balancing, rework reduction, improvement of the on-time delivery, or trick and the fixture improvement, ergonomics, shorten the lead time or shorten the production line length, even go for the energy saving, the pollution prevention and the control. Although the efficiency improvement for the administration process and the RD. Okay, so these all contribute, all have the impact to the competitiveness of the factory. So when we do the Kaizen project, we need to generate the saving. All right. So some saving are called the hard saving. Some others are the soft saving. Hard saving means the quantitative savings that could directly impact the profit and loss. Right. So the management care about this very much, such as the reduction of the manpower, saving of the energy, and the others. For the soft saving, that could be the quantitative saving and the qualitative saving not belonging to the hard saving. For example, the reduction of the lead time. This is difficult to be converted to the dollar sign, right? The inventory level down, the space saving, all these are important. Even the ergonomics improvement make the operator comfort to work, right? Increase of the safety. Okay, these are important, but may not be easy to use the dollar sign to say, okay, what's the value of this project? So this is called a soft saving. Okay, both hard and soft saving are important. All right, so if we like to have the hard saving, it's better to define the variable and define the formula. So the Kaizen team could use the formula well defined to calculate the hard saving to persuade the management this project has the value with the contribution. So if the factory want to take some execution of the Kaizen project, these are the typical structure we cooperate with the companies over the past 30 years. Introduction, team member, problem definition with the KPI definition, the target, and the gap analysis. We show the improved trend is the execution of the project, gain chart, fishbone analysis, Pareto analysis, stream length flow chart. We show the as is and the to be. The value stream mapping, typical lean tool. We show the before and after. How about the photo and the video to show what we saw on the shop floor? The calculation of the hard saving, soft saving, and we think about the Yoko 10 plan for the expansion of the results. Okay, so then we go to the introduction of the smart manufacturing. The definition is here, but let's take a look what are included in this term. The big data processing capability, industrial connectivity device and service, and the advanced robotics. Right. So this figure shows the robot density in the year 2021. The number of robots per 10,000 employees. The average worldwide is 141. All right. So if we review the key player, the Korea, 100,000 out of 10,000 employees. That means on the shop floor, one robot per 10 employees. All right. So this is a very high density in the factory compared to the other countries. Okay. So Singapore, Japan, Germany, China, and Sweden, and Taiwan, USA are the key players. All right, so go for the automation with the robots is one key issue for the smart manufacturing. How about the data side? Okay, so if we review the maturity index, computerization and connectivity are belonging to the industry 3.0. So many companies right now is still working hard to this part, connectivity. Try to get the data from the machines. For some equipment vendor, they may not allow the customer to do so. Maybe the customer need to pay to get the function of the connectivity for the data from the machine. But if we have this, we need to think about the 4 steps for the industry 4.0 or smart manufacturing. The visibility. What does happen? We see the situation of the factory. For example, some company has the situation room, or we call the war room, right, with a smart dashboard. So the management could see what is happening in his company or factory at a different location by the smartphone or by the PC, notebook PC. All right. So the next step is the transparency after we could see the data collected on the shop floor. So we try to see the logic. Why does it happen? We understand the logic. Then we go to the next phase, predictability. What will happen? So this is a big jump. If we could see a machine may break down, then we do something in maintenance before the machine breakdown, right? So eventually, the final target is the adaptability, all right? The self-optimizing. This is quite difficult, very much difficult. But if we consider the auto drive of the automobile, this is the target. Okay. So the next horizon for the industrial manufacturing include the connectivity, intelligence, and the flexible automation. Now we like to take a look at the Lighthouse Factory. Since the year 2018, by the effort of the World Economic Forum and the McKinsey Consulting Company, they try to see the front runners of the fourth industrial revolution for IR. So so far, about 5 years, 132 4IR lighthouses has been identified from the different industry sectors. Okay, so these are the benchmarks for the other company and the factory to learn from them. They are the pioneers. Okay. However, 70% from the surveyed companies are still stuck in the pilot purgatory. That means they still cannot see the significant benefit when they go for the 4IR, right? That means quite challenging and quite difficult. So the Lighthouse Factory provide 139 use cases that can get the double-digit improvements in financial, operational, and the sustainability metrics. So we could learn from them to save our time for the trial and error. Okay, so the primary obstacle to successfully scaling of the 4IR technology, the first challenge is the lack of the resource and the capability. All right, so in our cooperation with the companies go for the smart manufacturing, we see this is a big problem. Okay, and how about the lack of the strategy or the investments, leadership commitment, right? So for the lack of the resource and the capability, Lighthouse companies has a problem, but the non-Lighthouse companies see this problem even more serious. Machine learning, AI algorithms, opportunity in manufacturing, we care about the impact. If this machine is important to the company, when it's done, it impact the entire output. So this is the impact significance. How about the data richness? If we want to select a topic, we need the data to train the AI model. So without significant sufficient data, we cannot do the machine learning to get the improvement. So when we are selecting the topic, we consider impact and the data richness. Predictive maintenance is by far the most important topic people feel we could get the solid benefit if we successfully implement this project. Okay, so what does that mean? The predictive maintenance. Compare this, we could see the original maintenance is the reactive maintenance. That means we run the machine, it failed, we fix the machine. Run it, fail, fix the machine. So this is not so good because the machine failure may cause a big loss. All right, so we don't want to see this. So we do the preventive maintenance. We run the machine and we do the maintenance before failure, but we don't know the remaining life because we do not have the information to estimate when the failure will happen. So this is similar to the maintenance of our cars, right? If the garage asks us to replace the battery, we will ask, the battery seems still running okay, but we don't know when the battery will have the problem. Okay, so we don't like to drive our car and the car is dead on the highway. So we do the preventive maintenance. The problem is we may replace the parts too early. This is a waste of the budget. All right, so how to improve the predictive maintenance? We monitor the machine, okay, by the installation of the sensors. If we know before the failure what will happen, right? Then we could see, okay, if some situation meets, we do the maintenance right before the failure or sometime before the failure, right? So we could save the cost. We still make sure we don't have the failure to use the machine. Okay, so this is good. So if we consider the total cost, including the prevention cost and the repair cost, right? So the orange curve means the prevention cost. That means if we do the preventive machine, then the prevention cost will be high, right? We replace the parts too early. But if we do the reactive maintenance, that means we wait until the machine breaks down. So in this case, the repair cost will be too high. So the best situation is the predictive maintenance in between the reactive and the preventive maintenance, right? The summation of the prevention cost and the repair cost is the lowest. Okay, so this is good. So logical. So we like to execute this project. Okay, so we have the machine equipment here on the shop floor with a high impact, right? So impact is there. We like to see the data richness. Okay, we install the sensors. We collect many data, right? Including the temperature, humidity, vibration. Okay, these are good. So put the data in the data warehouse. We do the data cleaning, future extraction, and the many pre-processing for the data. So this is the big data processing. So after we have the clean data to use, we construct the AI model. We train the model and we use the model. This is the data mining. Okay. So have the model, we do the decision support. We do the predictive maintenance. When the machine is close to the failure, we replace the part before the failure. Okay, these are good. But the problem is, do we have this? Do we have this? Do we know this? Frankly speaking, many of us may not know. All right. So the issue of the data analysis is we need to use the AI models, right? So this is the selection of the right estimators. Are we facing the classification problem or clustering problem or regression problem or other problems? There are tens of or hundreds of models that could be used. Do we know which model work the best for our factory? We need to try many things. All right. Then the KPI. This is called the confusion matrix. The reason this is very much confused, right? The predicted condition, the actual condition. Okay, for example, if the actual condition is positive, negative, can we predict the result to be positive or negative, right? The actual is positive, prediction is positive. Okay, we hit. Actual is negative, prediction is negative. Okay, again, we hit, but this is the correct rejection, right? For example, this is the defect. But how about if actual is positive, but we estimate the negative? This is called the type 2 error in quality management. And this is the type 1. Actual is negative, but we predict positive. So only this 4 dimension is confused already. But how about if we add more evaluation to make this matrix more confused? Okay, for the smart manufacturing, this is something we need to use for the KPI. All right. So if we want to compare the difference between Lean and KPI, smart manufacturing, Lean is easier to execute, easier to learn and use tool, less expensive in investment, shorter lead time to get the benefit. KPI, the saving of the headcount, the balance of the line, right? The saving of the energy, easy to understand, could link to the saving. But as I just mentioned, the KPI for smart manufacturing is with the confusion matrix. Can we actually accurately estimate the defect rate? Can we estimate the parameters, right? This is not linking to the saving directly. So for the Lean guideline, we could achieve gradual partial improvement. But for the smart manufacturing, no. We need to pass a threshold to get the improvement, to see the benefit. Data collection in both project, but for the smart manufacturing, we need the big data. We use QC tools here. We use the AI tools in smart manufacturing. A consultant could coach the factory's guideline team to execute the Lean project. But for the smart manufacturing, we need a team to help the factory to execute. For the Lean, the factory teams are the execution force. But for smart manufacturing, the cooperation with the external partner is needed. Okay, so from Lean to smart manufacturing, there are so many things to do. But if we review the 2 dimensions, one is the Lean maturity, the other is the smart manufacturing industry 4.0 maturity. With the level of low, medium, and high, right? People say, if we go for Lean optimization alone, the cost reduction will be 15 to 20%. But if we go for the industry 4.0 alone, the saving will be 10 to 15%. This number is larger. This number is smaller. This is the figure provided by Boston Consulting Group. I think this number is meaningful because in our experience with the companies, we really see more saving by Lean optimization, right? But of course, the opportunity for the smart manufacturing is there. But if we could combine or integrate both, up to 40% cost saving is expected. Okay, so people may go from here to here in this way, or go for Lean first and then smart manufacturing. I would suggest, if possible, this may be an easier way. We see the benefits, we build our confidence from Lean, and then continue to go for the smart manufacturing. Okay, so if any company want to improve, this curve is quite typical. We see the significant improvements at the first stage. Then the improvement rate slow down, even become the flat. Then we need to find some other big topic to do the re-engineering to see the significant improvement again and again. All right. So if we could follow the sequence, Lean TPS first, EB automation second, and then smart manufacturing, I think we could keep the continuous improvement. That's good for our company to become very competitive. Okay, so this ends my presentation. Thank you.
Thank you so much for your informative presentation, James.
Yes.
Now we would like to move on to the Q&A session. Again, let me encourage viewers to leave their questions for Dr. James Chen with their name and country in the YouTube live chat section. We welcome your active participation. James, we have already received 3 questions from viewers. So can we start from them? So let me pick up questions from the viewers. Then the first one is from Enusha from Nepal. She's asking, could you please explain how developing economies like Nepal that are still struggling in industries 2 or 3 could be benefited from smart manufacturing?
Okay.
So, yeah.
I would say this is a very good question because I don't think every company should go for the smart manufacturing directly. Okay, so as Reed said, if any company is still in the industry 2.0 or 3.0, I would strongly suggest they go for lean production first, right? They need to eliminate the waste to save from the waste, so they could get the profit. So after this is mature, then gradually go for the digitalization, automation. So these 3 steps are the must before go for the smart manufacturing. For example, if we don't have the data, nothing to be analyzed, so impossible to do the smart or intelligent decision. All right. So go step by step. We could learn smart manufacturing first, but for the execution to see the profit benefit, go for these 3 steps earlier. Okay. I'm not sure if I answer your question.
Thank you very much, James. Then we have a similar question. So let me introduce. This is from KM. Should we do lean first and then smart manufacturing, or can we do at the same time? How long should we do lean before smart manufacturing?
Okay. Again, another good question.
Yeah.
I would say we need to check if we are matured here. All right. For some companies, they have the very strong execution force. They have a professional and experienced consultant. So the combination of the consultant's knowledge and the company's execution force, I think they could, jump from the low to medium, even to high lean maturity, maybe in 1 or 3 years, right? So if they could reach this level, then how about the installation of some sensors and the connection of the machines to get the data? So this may take some more time, right? If we have the database by accumulating the data over the past 2 to 3 years, we got sufficient data, then we could go for the smart manufacturing. So maybe in years from lean to smart manufacturing, but really depends on the investment, execution force, and the consultants' help. But some company may try to cooperate with the external partner. For example, they have the data, they don't know how to do the smart manufacturing. Some university professors like me or some IT companies, they have the experience in the industry 4.0 solutions, may help these companies to speed up the journey to smart manufacturing. Yes.
Okay, great. Yeah, that is a very helpful information. Yeah, we appreciate your answer.
Thank you.
Then we also have a question from Mr. Amit Kumar. Thank you for the presentation. Are there any specific case studies or examples where companies successfully navigated the productivity paradox during their journey from lean to smart manufacturing?
Okay. Yeah. So if any company want to go for this journey, it's better to learn from the other pioneers to save the time for the trial and error. So maybe let me use a Lighthouse example to answer this question. Okay. There are 132 lighthouses worldwide so far over the past 5 years, selected by the McKinsey company. So several groups, for example, one group here in Europe, another group in China, including some areas we could see that Japan, Korea, and even Taiwan. Okay, some in India. All right. So these lighthouses have the successful journey with respect to the improvement in productivity, speed to the market, agility, and sustainability. Right. So these are the KPIs most companies are hearing about: the factory output increase, productivity increase, the OE considering the efficiency, the availability, and the quality, or the cost reduction. For example, the quality of cost of quality. People care about the internal value, external value, appraisal cost, and the prevention cost, right? So these are important. And if we review what impact they could reach, okay, the improvements, we take a look at the KPI of the productivity. So for the factory outputs, productivity increase OE, the improvement rate could be, some numbers to 400%, 4 times. Okay. So if we review the improvement by 2 categories of the factories, one is called the factory lighthouse. The other is the end-to-end lighthouse. Okay. Factory lighthouse is in the dark blue. It means the single factory. End-to-end lighthouse means the supply chain. Okay, the lighthouse factory and its supply chain in the light blue. All right. So the improvements for the different KPIs, we could see a mix of the factory lighthouse and the end-to-end lighthouse. So this is fine. But the interesting part is this one. If we consider the agility and the speed to the market, the end-to-end lighthouse could gain even more saving, right? We could see the light blue parts dominates the dark blue parts. So I think this is reasonable, right? If we could integrate the key players in the supply chain, we could reduce the inventory, right? The different parts, different organization in the supply chain, they have the transparency in the information. So if I know the inventory level of the customer and the vendor, of course, these players reduce the inventory level simultaneously. If the inventory is reduced, lead time, of course, will be reduced proportionally, right? The changeover time will be shortened. Okay. How about the speed to the market? Again, if we know what customer wants and the need in the future, we could reduce the speed, the time to the market. Okay, so these are the interesting part. For the agility and the speed to the market, supply chain lighthouse can achieve even better saving. So also the sustainability, the lighthouse could have some benchmark for us to learn. All right. So I'm not sure if this answered the question.
Thank you very much, James. So this is an additional question regarding that one. So can you give us your opinion? What were the key factors for those successful cases? What do you think about it?
Okay, so this is the other interesting question. All right. The key factor include several parts. The first part is the company themselves. The strong support from the top management, I would say, is the must. Okay. If the top management cannot support this lean Kaizen or smart manufacturing project, I don't think this project will work. Okay. So for the cooperative companies, I participate for this 2 type of project. Almost 100%, we got the strong support from the top management, including the chairman and the general manager, even the vice president, right? So with their support, the company could form the Kaizen team. So for example, I'm the consultant, I'm the coach to evaluate the progress of the Kaizen project. So I'm the people who provide the training to the members who may not know Lean, who may not know the smart manufacturing, right? So we expect the top management's strong support. That's a must, because this includes the investment, right? For the smart manufacturing, we may need to buy the sensor to install the sensor on the equipment. We may need to buy some computer with the more power to run the algorithm to train the model. Okay, all this need a investment. But for smart manufacturing, if the company want to build a team internally, the member salary may be different from the other employees. For example, if people understand AI, they get the master or even PhD degree in this area. If a company cannot pay them well, I don't think the company could keep this team, right? Some people may leave. So again, this is the investment, all right? So if with the top management's support in many different aspects, the team formation, the organization, the investments, I think we get a good initial start. But smart manufacturing has many areas. It's better for the company to have some cooperation with the external partner. For example, right now I'm leading the graduate student team working with some companies. They are the Lighthouse. Okay, they are one of the 132 lighthouses worldwide. So even for the Lighthouse Factory companies, they are cooperating with the universities and the research team. So I think for the non-Lighthouse companies, it's better to identify the partner you could trust and have the long-term relationship to work together to the journey of the lean and smart manufacturing. Yeah, this is my feedback.
Yeah, great. That is very interesting and encouraging. Thank you so much. Then we have more questions from viewers. So let me introduce. Yeah, then actually this is what I wanted to ask. Yeah, also, and that is about the SMEs. Yeah. So this is a question from Mr. Zainu Juri. Professor James, for SMEs with less financial capital, what type of smart manufacturing method that they can start? So is it different from the approach to the large companies? If different, can you tell us how different it is?
Okay, very good question. I think this question was asked many times in my cooperation with the companies. Okay, for the journey to the smart manufacturing, it's better for the big companies, large companies, because they have the manpower, they have the capital for the investment. So easier for the big company to get the initial start. But even for the big companies, some senior management may not know what is smart manufacturing. So the training to get the correct concept of the smart manufacturing is important for the top management. All right. So you need to identify the lecturer, professor, or consultant who really know the smart manufacturing. They are not only learn from the literature, learn from the textbook. They need to have the real experience in this area, right? To see how the other companies success in this area. Okay, so the concept training is important for both large and the SME. But for the execution of the smart manufacturing projects, for big companies, they could build a team by themselves, right? But still, they could cooperate with the external partners. But for the SME, they may not have the sufficient budget to invest in this area. I think the initial stage should be the cooperation with the external partner. Even though the SME could form the internal team by themselves, but in many cases, they cannot keep the team. When the team member experience some successful project, they may leave, unless you pay this team with a very high salary, or these team members are very loyal to the company. But the risk is there. Okay, so I would say if we want to go for this smart manufacturing, the cooperation with the external partner, no matter for the SME or big companies, is a very important strategy. Okay, in Taiwan, even for the big companies, they still work closely with the top universities in this area. But for the lean production, I think we may not need to cooperate with too many partners, because this is more internal project, right? But experienced consultant will be very helpful to avoid the trial and error and waste too much time in the learning of the process. Okay, my answer is this.
Yes, thank you so much. Then we would like to move on to the next question from another viewer, which is about dairy farms with cow. So, so this is a specific question. How we can make a dairy farm with 500 cows from lean to smart manufacturing? So this is from Dr. Rafiq from Bangladesh.
Okay, wow, this is interesting. Okay, most of my experience are in the manufacturing sector, but in fact, I work with some project for the smart. I should not show the smart manufacturing, smart farming, smart agriculture. For the fish farm, they are using the seawater for the grouper. Okay, grouper is a big fish with the high value. The customer enjoy the meat. Okay, I think we could think about the farm is not so different from the manufacturing. We could monitor the animal, right? We could do the scheduling to feed the animal. It's just like the material provided to the animal, all right? So if we analyze the flow of the process, we could see the waste, right? I would say 7 waste, 8 waste is always there. We could use the typical tool for the lean analysis to identify the waste, to identify the opportunity for the improvements. So if we do this, of course, we could go for the automation, like the auto feeding device, right? We measure the timing, we measure the animal's behavior. We know when is the good time to provide the food to the cows. Okay, and we could use the image processing to check if the cow is sick. Okay, we did the same thing to capture the image for the fish and to identify if this fish has some problem on the skin. Okay, so similar idea could be applied, but of course, for the application in different industry sectors, some modification is needed. Right? So think about the basic idea of the tools and in the application at the domain knowledge to integrate. I think the successful opportunity is still there. That's my answer.
Okay, so the concept of smart manufacturing can be applied to other sectors, not only manufacturing. Yeah. Thank you so much. Okay, then now we have received 2 questions related to human capital. So let me introduce 2 questions. Yeah, then that is also what I wanted to ask you. Okay.
Yeah.
So the first one is from Mr. Chandan Chaudhary. If smart manufacturing lead to job loss of employees, how we can convince them to adapt it? Then the next question is from Mr. Diala Ftabarian. Professor James, how we can convince employees to go for upskilling and in mining and the refining sector? What kind of training should be prioritized? So we would like to ask about the human skills. Yeah, in the manufacturing, in the smart manufacturing. Yeah, can you give us your insight?
Okay. Top questions. Huh? Okay. For the first question, if any company go for smart manufacturing, they may cause the job loss. Okay, yeah, this may be something related. But think about the e-business. If we review the past 3 decades, many companies go for the ERP, okay, enterprise resources planning system, like a SAP, like the Oracle. Of course, the system replaced some people, the worker in the office. But if a company could have the adjustment, right, shift the worker who work on the original, accounting and finance jobs to other roles in the company, I think we could still find a balance, right? The system, no matter it's the software system or the smart manufacturing system, they could increase the efficiency and the productivity of a company. And company use the the talent pool, HR talent pool, to think about how to fit the people to the job and how to fit the job to the people. So there should be a balance between these. Okay, so this is the management, not the technology itself. Okay, but right now, I would say, at least in Taiwan, it's quite difficult to find the operators or skilled operators for the manufacturing companies. So that's maybe some of the reason people try to use now automation and the smart manufacturing to cooperate with the operators. Okay, so this is my comment to the first question. So your second question is the smart manufacturing in the mining industry.
Yes, mining industry.
Frankly
How do
speaking, even I work with different industry sectors, I didn't touch the mining industry. So I would say, of course, the domain is different from the others, but maybe if we could get a chance, we could see the flow analysis or what's the current situation, current problem in this industry, and then of course we try to use the tools to do the analysis, or if any company could provide us some data, some problem showing what's the pain points in your company, your factories, we could try to think about using the typical tool in lean and the smart manufacturing. I'm quite sure we could make it better, right? Guideline is everywhere, opportunity is everywhere. If we could identify the waste, we could see the problem. We will find some way to solve the problem, more or less. All right. So think about the tools, think about the basic ideas of the guideline, and then find the opportunities. All right. So I don't experience it in that industry, so difficult for us to answer directly. Yeah.
Yeah, but your advice will be helpful. I believe so. Thank you so much.
Thank you.
Then yeah, we are running out of the time, so I would like to ask the last question from
Yes.
myself, which is about the government support in the Republic of China. So we are curious how smart manufacturing in the Republic of China has been developed. So is there any government support for lean and smart manufacturing in your country? Could you share it with us?
Okay. Yes. I think Taiwan's companies are the good players in both lean and the smart manufacturing. And the government support, yes, we have the government support in both areas. In fact, I was the reviewer to help the government project to help the companies to improve. Okay, so for some companies, they feel if the company run the lean and the smart manufacturing by themselves, they could get the benefit directly. So the benefit is more than the investment. So for this type of companies, they do not apply the government support. They just run it by themselves. By the cooperation with the professors in university or some consulting companies. Okay, but for the other part of the company, they feel they are at the very initial stage. They are not so sure how much benefits they could get, or they want the financial support to speed up the application. So they apply the government support in both category. For the SME, I think the support may be from some number like the $30,000 per year. All right, this is some small support, or to the big companies to run the big project. The support may be from the $0.5 million to several million US dollars, depends on the investment of the company. Right, the company need to invest, and the government provide partial support. So that's a good way to help the company at the initial stage, because they save some cost and they see the benefit. And the government also want the company to get a support. They need to show the successful case to attract the other companies to follow. All right. So some support from the government is there, and it's important. Yes.
Yes, thank you very much for your answer and sharing. Then just now we received one more question from the viewers.
Okay,
so
sure.
Can I pick up that one? Thank you very much. So this is from Kakir. Sorry if I'm wrong. Gradual improvements was pillar of lean manufacturing, but in smart manufacturing, shop floor processes would be very standardized. So will it lead to lose human innovation potential? Can you share your view on this?
Okay, if we go for lean first, we could create a SOP. We could have the standardized process. Okay, that's good. But if a company only has the standard without the improvement, that's hurt. All right. So standard is there, but standard is there for the improvement. So we need to set a standard, have an SOP, and try to execute a Kaizen project to improve. Then we revise the SOP to a higher standard. All right. So standard is there as a must. So based on the standard, we collect the data from the current process. So the data could be analyzed, could be used for the AI model training. So we could do the prediction. All right. So some opportunity in smart manufacturing was something like the prediction to avoid the failure. Right. We should replace the parts for the machine, so we will not see the machine failure. Right. This is the maintenance. We make the better decision for the scheduling. For some other big questions, we may not use our experience to optimize the decision. Okay, so with the Kaizen to build a strong standard, and with the improvements to revise the standard, we could use the data to go for the next phase improvement by the smart manufacturing. I'm not sure if I really answered the question.
Yeah. So your point is that smart manufacturing will not lead to lose human innovation potential. Rather, human can be more innovative without smart manufacturing. So is that right?
Yes, innovation could be used in Lean and Kaizen. But for the smart manufacturing, in addition to the innovation, we still need the IT skill, AI skill. Okay, so for any employee who has the innovation, they could execute the project in Lean Kaizen. Right? Innovation, think about some good idea and try. But smart manufacturing need to combine the innovation with the data, with the IT tools, with the algorithm, because the structure of the smart manufacturing is quite different from the Lean. Okay, so Lean could be jump around, but smart manufacturing need to build a model to get the optimal decision. So innovation will be there, but integrated with different methodologies. Yes.
Okay, thank you very much for your explanation. So we are almost at the end of the session. James, as a conclusion, could you give a message to our viewers who are watching today's session?
Okay, let me go to the slide here. I would suggest for the companies, if you never touch lean and never touch smart manufacturing, it's better for you to go for lean first, right? To identify the waste, try to get the benefit as soon as possible. So after you eliminate the waste, you collect the data, you have more and more data. It's time for you to try to go for the smart manufacturing. But the data collection or automation should be after lean, right? We have no waste. We have the standardized process. Then it's more meaningful to collect the data from the standard process. Okay, if the process is not stable, then data collection may not be used in a better way. So lean first, and the EB digital second, automation second, then smart manufacturing. So if you follow the sequence, you cooperate with the good partners, I think you will enjoy the journey of lean and the smart manufacturing. Okay, so this is my ending remark, and good luck to this journey. Thank you.
Thank you very much for an inspiring message, James. We really appreciate your time today. So we learned from Dr. James Chen about from lean to smart manufacturing. I hope this session provided helpful information and inspiration to all of you. The APO will host more productivity talks and other digital programs with different guest speakers. Please join us next time. We'll be looking forward to seeing you. Now, I want to thank again for everyone for joining us for today's session. And thank you very much for coming, James, and answering to the questions. And please take care and goodbye.